So, welcome back, everybody. Hope everybody's refreshed from lunch. So we can start from Greenfield again now, which is not what Mufrid Krilic is doing right now, because he's talking about legacy code. And he will tell you what line-bounded contexts within subdomains will do in legacy code. Have fun.
Thank you. Thank you for that nice introduction. Well, I heard a scary thing this morning in the keynote. Matthias was going all through these concrete examples and experiences, and he mentioned you can never tell a real story because you need like 2 weeks to understand the domain. Well, that's what I'm trying to do in this next 50 minutes. So this talk is a homage to my former teammates. A way of saying thank you to them for good times, bad times, hardship we endured together, and things we learned. So right now I go about and present myself as a domain-driven design coach in a small consultancy in Norway called Cowork. There is a specific technique we use in Cowork we call titleless tight, and I will be referring to it later on in my talk. We have actually a partner here in Germany doing training in titleless tight, so you might check it out. And there is another peculiar thing about Cowork that I will want to share with you. We are kind of leaderless organization, no managers whatsoever. And it's all based on this book, Reinventing Organizations by Frédéric Laloux. It is kind of controversial, a lot of criticism on this book, but since this is a personal story, this talk, personally this book changed the way as I see the work itself. So I will recommend it for some light reading. It will either inspire you or provoke you. So let's start this story. So this story is about team dealing with a legacy system. And the legacy we inherited was a well-established product in a highly regulated market, healthcare. However, the team that built the thing was not there anymore. Those things happen in organizations, right? People leave, people get assigned to new tasks, people want to do something else. So there was some people left, but mostly they were gone. And this was kind of rather critical for the company. The business case was the system that helps physicians prescribe medications in hospitals. And we also need to integrate with a system that delivers the prescriptions in pharmacies. And of course, safety is paramount in those cases. So it's a mission-critical system. System is there, and but not many people that built it was still around. The legacy we brought with us was a kind of combination or mix of junior and senior people. However, we had little to no experience of this domain, particular domain. Some of us had a quite long experience in the market of in the domain of healthcare. However, our knowledge of this particular domain was very limited. So we took up the challenge and let's go on about it. What can we do? Let's try to find some motivation. So our inner motivation, let's make sense of the domain, let's make sense of the legacy code. And we want to provide some value, of course. So in this session, I will be focusing on those first two parts. How did we go on making sense of the domain and of the legacy system itself? So let's start with the domain. So we started by asking domain experts, they were still around, starting to asking them, what is the core use case? Why did we build the system in the first place? Okay, this is, we want to prescribe medications. Okay, let's see how we can visualize this process. Luckily for me, I was kind of part of DDD community for some time, so this community provides plenty of tools for dealing with complex domains. So I landed on domain storytelling. Hopefully many of you are familiar with it. If not, this is rather easy to comprehend, which is the reason I use it. So we start this. Patient has consultation with physician, and physician, during this consultation, decides to prescribe medicine. However, to prescribe a medicine, the medicine needs to be on this list of officially approved medications in this country. This is Norwegian healthcare market. So Norwegian authorities, they maintain a list of the medicine that are allowed to be prescribed in hospitals. So in order for the physician to prescribe a medicine, physician needs to find that medicine in this database. Assuming that she or he does that, she can then send the prescription to this system that integrates with the pharmacies, which notifies the pharmacies, leaving the patient to collect the medicine. All fine, all good. So we kind of understood that. The angle from this side is rather okay, this is it. This is kind of the coarse-grained business process. Happy with it. And of course, being from DDD community, starting questions, okay, how about some subdomains? Is this all one thing, or could we split it up? Okay, let's see if we can find some subdomains. So we could, based on this analysis and using the information flow between the actors and systems, we can say, okay, consultation, that's a subdomain, finding pre-approved medication, something else, sending the prescription, and collecting the prescription. It could be. Seemed like a reasonable division of responsibilities. Of course, for us as a new team, it was rather important to reduce the cognitive load, as team topologies teaches us, right? To be able to move around in the legacy code. And then we made this assumption. Our assumption was, assuming that we hit the target with those subdomains we just shown, there should be some kind of boundaries in the legacy code that confirm that assumption in some way and at some level. So some alignment should be there already, or some indication of alignment, not at the way that we wanted, but to a certain degree. So this was this assumption we worked, we started from. Okay, but looking for those hidden boundaries, where can we look for those boundaries? So we started to ask questions, what is a boundary? And there are some easily observable boundaries, as I see it, like network, that's a boundary. Two parties talking across the networks. Network between the parties constitutes a boundary. Both parties can agree on that. Technically, when you deploy something, you put inside a container or whatever, what goes on is inside the boundary, what's not, it's outside. You can point at it, okay, I see it, I agree, that's a boundary. Your organization constitutes, it has a number of boundaries, your teams, your departments. Within the team, your communication is more efficient than outside the team. So those boundaries are easily to observe. How about those are not so easily observable? At that point in time, we discovered a rather interesting model called 4+1 view model of software architecture. It was a paper released by Philippe Kruchten in 1990s or something. And the message this model trying to convey that each distributed system could be perceived through these four perspectives. each representing a certain point of view for a given stakeholder. So if we start with the logical view, that sees the system through the lenses of end user. What are the logical parts that stay together, or they belong together, or the parts that could be separated? What are the parts that user need to be cohesive in order for user to do their job? So what logically belongs together, what does not? When we go to development view, suddenly we as programmers become stakeholders. That is, how do we structure our source code? Mostly on what kind of repositories do we create, how many? And immediately we see that what logically belongs together does not need to belong together in development view. So we can, for whatever reason, choose to split things that logically are cohesive to different repositories. It happens. And we can do the other way around. Things that are logically separable, we put them together. When we go to process view, the perspective is deployment. How do we package those logical components and source code constructs? How do we package them together? Do we have a simple deployment strategy, putting everything in one package, or what? Or do we distribute it? The physical view is the perspective of infrastructure. Where does your code run? Is it a desktop application, mobile application, or database with a cloud or on-prem, with database with so many nodes or so what? So it could be this different manifestation of infrastructure you see in the physical view. And what drives these evolution of those views are scenarios, use cases. For each use case, you challenge those views. They get modified along the way, but not every view at the same time. This was rather interesting, kind of giving us a toolbox to apply this model the way it could benefit us. And we discovered at least two ways to apply this. We could either establish logical boundaries without distributing, so still a distributed system in a way, but logically separated. Or we can have these coherent logical components that are distributed across other views. So I'll try to sketch this. Like conceptually, we find there are some, in our source code, there are some functionality that logically belong together. And we make a strong cohesion between those parts. Those parts that do not logically belong together, we keep them lowly coupled. But still, they are within the same source code repository. So we have logically split things apart, but we have not distributed them in development view. That's what some people call modular monolith. And then you can go the other way around. You can logically make a boundary around certain business rules. So you have a set of your classes in a namespace or whatever programming language you use, and we make those classes responsible for a set of business rules. And then we replicate those business rules across our application. So for each, whenever those business rules should be engaged, the same code gets run. So the code, this is more replication than distribution. So you distribute instances of the same logical unit. Okay, so there were at least two ways to apply this model. And then we started asking ourselves a question on dependencies. What can 4+1 model teach us about dependencies? When we say there are too many dependencies, what do we actually mean? And it turns out that those dependencies that we need to pay most attention to are logical view dependencies. These are kind of the reason for coupling. Now, coupling, of course, can be a good thing if you go explicitly about it. Certain parts of the system you want tightly coupled. That's okay. But if you want to define coupling, you can use the amount of data that is passed across the boundaries. The more data you send over the boundary, the more coupled it gets. And so it answers the question, how much do the different parts of the system know about each other? So you can go home and look at your APIs and see how much data is actually being passed around. It can give you the sense of this logical coupling, which means that we risk distributing our dependencies. So if we distribute our logical dependencies, the cost of dependencies goes up. Because the logical dependencies, they have this gravitational pull. They want to be together, and you distribute them across your source code or your process views, and you pay the price. So, or even across the organization, right? Different teams doing different parts of the system that are logically cohesive. So when you design microservices, this could be something to consider. Now, first time I presented this talk, I defined this metric for systems that are hard to maintain and hard to change. And I called it amount of logical interrelationship between different parts of the system. I didn't like it then, I don't like it now. Luckily for me, Vlad Kononov gave a great talk at DDD Europe this year, called The Fractal Geometry of Software Design. And he put it much more precisely and simplified. The cost of change is proportional to the distance between components. Now, when Vlad presented this, I made this connection that, or assumption that, okay, there could be a relation between what he is presenting and 4+1 model. So I'm eagerly awaiting this book to arrive. I guess it's due this fall. To see if it fits the mental model I made in my head. Okay, so armed with this knowledge of boundaries and dependencies, how could we apply it in our concrete use case? So back to our story. Now we stumbled upon another use case. I mentioned that for each medication in the healthcare, you need to find that medication on the list of pre-approved ones officially by the authorities. Well, it turned out there is exception to this rule. And it goes like this. We still have patients consulting with physician, and physician during consultation finds out, okay, you need this medicine. However, when physician looks up that medicine in this database officially approved, she does not find it. So what she can do about it? Well, she can send an application for that specific medicament to national authorities. This is perfectly valid process. So she can send an application for it. And this is a real world case because different countries have different lists of approved medications. And some countries have shown some promising research on use of a certain drug. So our doctor is paying attention to research and can use documentation from that research in her application. Okay, so she sends an application and gets response back. It's approved. And then we can go on and send prescription to this pharmacy delivery system, which notifies the pharmacy a patient can collect the medicine. At that point in time, suddenly realized, wow, this could be another subdomain. Could this be opportunity to reduce our cognitive load? Because we were still looking at the legacy system in front of us as one piece of work. There's only We couldn't realize what goes in, what are the different parts of it. But we could communicate with our domain experts about the business process, and starting from that, we could trying to derive the subdomains and see if they apply to the legacy code. So, okay, could this be another subdomain? Okay. What actually constitutes a good subdomain? I don't know. This event, non-approved medication prescribed, is it significant? In event storming, they call it pivotal events. Could be. However, there was this notion of time involved. When physicians sense this application, the business process of prescription stops. The physician goes on and does something else. She waits. So there's this temporal distance. When the approval arrives, then the process continues. So this notion of time prompted us to consider this as a valid subdomain. Okay, so we sketch this like this. There you go. This is our new candidate for subdomain. Okay, and back to our assumption that if we correctly identify subdomain, we should find some traces in the legacy system. So let's start looking for bounded contexts. So now we are going to more technical part of the session, and this was a .NET project. My background is from .NET. I presented this to a partner of ours, and feedback was, well, not everybody is familiar with .NET terminology. Still, that was .NET project. So it will be a lot of some .NET references. I'll try to provide some Java counterparts if it helps. Okay, let's go on. So what are the traces of bounded? Can we find some traces of the bounded contexts? Can we find any established boundaries? Perhaps the steam before us had arrived to the same conclusion. We don't know, they are not there anymore. But perhaps they all considered the very same questions at the point in time and concluded the same. Perhaps there is something in the code that could point us that this was correct. So have there been any attempts to isolate these pieces of code before? It turned out there was. There was something in our source code structure. We found some .NET projects and some namespaces that seem to contain the logic exclusively reserved for sending this application to national authorities and getting the answer back. It seemed so. You never know, but you look at the code, well, looks right. But we were diligent enough. We did another step. We did a rather detailed, thorough analysis of the dependencies or those parts of the code that were identified to constitute that bounded context. So we went through different steps, like going through the using statements in the code, references on project level or package level, what remote services we were communicated with, did we receive any events, did we push any events. This was rather time consuming, but it turned out to be essential because it confirmed our assumption to a certain degree. Yes, there seems to be a valid reason to set this code should be separated. Okay, so let's draw a context map. So our assumption was that we could define application-bounded context having a conformist relationship with prescription-bounded context. And the dependencies are going one way, from downstream to upstream. That was our assumption. However, we were in the legacy code, right? So you have to respect the existing dependencies and relationships. You need to go on about a bit more careful. So we felt we needed like an explicit decision on the amount of work needed to break the monolith. Not just conclude and let's do it, but let's see how much time do we actually need to arrive to something that is workable or actionable. So, and of course we wanted to keep the business running all the time. So what is responsible decision to take in these circumstances? Okay, so our decision was, okay, let's establish this bounded context and let's establish observable boundary. So in .NET, we established this Visual Studio solution, which is a folder or set of namespaces. But we will keep this core bounded context as is. No changes there. If possible, 1 week. All developers hands-on 1 week. And whatever we find out, we will summarize the lessons learned. So something good will come out of it. And this is where this method of tight loose tight come into play. This was rather concrete implementation of tight loose tight. We didn't know that the name at the time, but now it has a name. And because on first tight, you agree on your goal and purpose, and then you have like this creative period of reaching that goal in some way. And then you have a last tight when you have a feedback to your assumptions and hypotheses. So this was an example of tight loose tight in action. And one more thing that I mentioned, that this 4+1 model had two ways to apply it, and we chose the first one. So we chose to make logical boundaries within the same source control repository. So we did not choose distributing more. First logically split and then see how it works out. Great. So let's go on. We start this 1 week period. So the first step is just to establish this boundary. And so the concrete thing we did was just to move code around. So we just moved the code with Git from one folder to another. And let's compile it and have the unit tests run. All fine, all good. Okay, you need some early success, right? But then we run into one dilemma, rather essential one, very quickly. What about those other kind of tests and unit tests? I'm not sure. People call them by different names: integration tests, end-to-end tests. Those tests that kind of span multiple components. As I see it, at some level, unit tests rely on mocking out dependencies and thus do not provide real feedback on how a system will behave runtime. Those integration tests are meant to do that. And some of them were failing. It was rather cryptic messages. So what shall we do about it? Should we work on those tests or not? So if we work on those tests, we will get feedback if this would work runtime. However, just the amount of work to get them up and running was deemed to be considerable. It would consume most of our time box. So maybe we couldn't get any feedback. It was like a difficult one. So we chose to focus on unit tests only. This was an interesting decision. Okay, step 2. Let's clean up obsolete references. So we moved code from one place to another, and the place where we moved it from still contains some references to what you call the non-existing code. Let's clean those up. It should be an easy job. So let's clean those references and using statements that are obsolete. This uncovered hidden dependencies, rather interestingly. It turned out that this is our context map, our target context map. However, it turned out there were some code, some classes and interfaces defined in this new context, referenced from this core bounded context. It should not have been that way, but it was. Okay, so this seems rather like a circular dependency. You don't want to have that. So what can we do about it? So we established what we in DDD call a shared kernel. So in step 1, we have prescription context referencing application context directly. However, we moved those types that were referenced to shared kernel, and we made both context point to that shared kernel. Seemed to work. Great. Even more encouraged about our success, we boldly, I think it now is talking about day 4 or something, let's deal with those end-to-end tests. And it didn't work out. This was kind of end of it. It turns out that there were some tests that required code from the both contexts to be present at the runtime. So our analysis upfront did not discover it. But when we finally got those tests running, we discovered this dependency between two contexts that are going in the different direction. It was going from prescription to application bounded contexts. And it was a valid business reason for this. So we unlocked this business requirement, achievement unlocked. Should I have a badge for it or something? So as a physician, while you're prescribing non-approved medicament, you need to see prior applications, because some patients are having the same medicine on a lifelong basis. There are certain diseases that require that. And physicians need to see what has been applied for before, if it has been applied for before. So this required dependency. While prescribing, I need to see those applications that you sent, that I or somebody else sent before. It was a requirement. And naturally, there was dependency in the source code between the code that maintained the prescription part to the application part. Now, in retrospect, this could as well have been related to this shared kernel thing we did in the step 2. Didn't realize it at the time, but it could have been an indication. Instead of just going on the movie code around, perhaps you should just start asking some deeper questions. We could have asked somebody, but I'm not sure who mentioned it. But there is some, you have this known unknowns, but you have also unknown unknowns. This was one of it. So we didn't know what to ask. The knowledge was there. But we stood for the questions. We were not up to the task. Okay, we are still in the game. Can we avoid these circular dependencies? This is just tests, right? This is just tests. Let's do something. Let's get these integration tests running, and the production code will take care of itself. So let's establish a new module called integration tests that can get every code, every piece of code that it requires, and just get them running. It will work. However, we would still have this production level dependency between those two contexts, even though the tests were running. So you can have tests running. Once you deploy them, you get another feedback. So 4+1 model teaches us this, that you can, deployment-wise, you can work around this. As long as you deploy everything together, it will work. But it kind of tightens your hands, right? You don't have this opportunity to split things apart because you have circular logical dependencies. So it was not what we wanted. So we just kind of, okay, this was our last attempt, and let's close this chapter. Okay, now what? As this lovely gang of fishes from the wonderful Pixar movie Finding Nemo, they had a great escape plan, attempted it multiple times during the movie. They finally got it at the last attempt, but there was a flaw in the plan. So at least I got to write a blog about this. I felt kind of it was an interesting story to convey to a broader audience. And so I got one suggestion, a rather interesting suggestion on my blog. How about if you analyze the needs behind the business requirements? Right, you get presented your requirements more often than not as kind of form of informative solutions. To my experience, I rarely see the requirements formulated as needs of the user or somebody else. Could we actually analyze the needs behind this business requirement? Okay, let's see this user story once again. As a physician, while prescribing, so the action here is prescribing, I need to see prior applications. So the action is still prescription. The data you need to see is applications to be able to prescribe. So we are still on prescription action. So this is the action. This is the behavior of the user. User wants to prescribe a medicament. So what can we derive from that? Well, user needs only to see prior applications. No actions is executed on the applications themselves. The action is still on the prescription side. So this is decision support data we're talking about, which means a read model. Okay. So what we got is this design. We have front end, we have back end, we have application context, we have prescription context, and in application context, the only thing that application front end shows is this application form for user to fill when sending the application. While on the prescription side, we have, of course, the functionality to prescribe the medication, but we also have this functionality that shows past applications, because backend on prescription server goes on and fetches the data from application server to find those past applications. So this was this circular dependency. It goes around. And we can move from this to this. We can move the responsibility to show past applications over to applications bounded context, and still show that in the on the front end. So we have we still keep the logical parts of the system that user needs to see visible to the user, but we have split the responsibilities apart. And this method is known as view model composition. So the one who suggested this to me was Mauro Servienti. And as a token of gratitude, I linked to his blog. He has a lot of information on view model composition. So you compose data from different contexts on front end. It kind of makes system more loosely coupled if you push those dependencies up to front end. Okay, so that's something to work on. We were past this self-imposed deadline on 1 week, so the system is still as it were at the start. However, we have learned something. We are still in this tight, loose, tight process. Now in the last tight, let's summarize the learnings. And there were quite a few things that we have actually learned. So I pick up 4 significant issues. First, we decided that we need a more thorough approach to analyzing the boundaries and subdomains in the system. So we decided to start these weekly sessions in the team, sometimes getting people from outside the team to help us, to discuss these kind of issues on boundaries, subdomains levels. What makes me really happy is that my former team still does that. So they still have this culture of meeting and curiously checking, are we on the right path? What have we learned? And what, in retrospect, what I saw is that perhaps there is another model here lurking in the scenes, or perhaps there are different questions to be asked. This is kind of one of the, I guess, one of the most useful properties of a DDD practitioner, knowing which questions to ask at what time. So perhaps this domain storytelling sessions was telling us something, but we didn't ask the right questions. So let's go back to this perceived subdomain division. It looks quite okay and quite correct. However, perhaps the naming of the actors and the system is here is far too general. Who is this physician? What is his or her specialty? Physician could be neurologist, cardiologist, gynecologist, something. There are many specialties out there. So we just denoted it as physician. Something is behind this question. Perhaps this non-approved medications application and prescription is specific only to certain fields. I don't know. It could be. Because we just generalized all the physicians into one actor. So we missed the nuances of their workings in the daily actions. And what about patients? Not every patient is the same. You come with your own needs and the different diagnoses. So by naming the actors in general fashion, to me it seemed that we pulled towards a more general model. So not necessarily meeting the user needs. So by more nuanced naming, we may discover a more suitable model. So this was something that domain storytelling can help us. Of course, learning as facilitator to ask the right questions. And which brings us to, this is rather, what you call it, non-expensive exercise to run, even if you're legacy system environments. If you have your domain expert, you can always run it. It won't take a long time. And you can, by repeating these kind of exercise or doing other collaborative modeling techniques, you arrive at what we may call a target model. The way we understand the domain. So, and then if you can, along with the domain experts, agree on, oh, this is the way it should be, then you ask a question, how does legacy system fit in? So then you work towards a target model. And one of the issues we had is with these unknown unknowns I mentioned earlier is how do you maintain the knowledge in your team and your organizations when you're talking about span of several years, perhaps even 10 years or more? Well, I would suggest techniques like impact mapping or user story mapping or something that in visual way keeps this knowledge explicit in your team. Another thing which was rather concrete and very helpful was enhancing our code reviews practices with a set of questions related specifically to dependencies. Now, so during the code review, you pay particular attention to introduction of new references and new dependencies. And this is where your IDE can work against you. I won't name any, but I'm not sure if anybody is in the audience working with. But sometimes those IDEs tools just are too eager to suggest introducing a new dependency from another place. And you can, during code review, you can ask the question, what was your intent? You actually intended to make this reference, to get this dependency. So paying attention not only to tests and production code, but actually to dependencies introduced in project files or Maven files and source code itself. But this requires discipline. This is not something that is more a culture building thing. But this worked out rather good for us. And you can always make things more cohesive. A wonderful talk by Kent Beck a couple of years ago from DDD Europe, that as well. So how can that help us? Well, you can keep things separate until you learn what they are. And then if they turn out to be different, then you keep them separate, give them proper name. Naming is not easy, but anyway, you have learned. If they turn out to be the same thing, well, it's easy to make them cohesive. That Kent Beck showed us. So that's about it. Now comes the most important part of my talk. I hope you enjoyed it. I certainly did. This was all fine and good. But now comes the real important stuff. Please allow me 1 minute on this one. I'm not sure how many of you have heard about First Lego League. It's a fantastic project to engage kids aged 10 to 16 to get more interested in science and technology. So they have this scientific project in 8 weeks, and they need to deliver the projects, and then they need to program Lego robots as well, and compete against other teams in a rather short time frame. So what I would, hoping that it's okay to ask you to consider using a little bit of your time on First Lego League, because I feel it's our responsibility as practitioners to get more, invest in the future generations. There are teams all over the world, and there are competitions in Europe right now. You can start by just involving as a judge. It will take just a little bit of your time. I use quite a bit of my time. This is my team, Techno Builders. These are our robots, and they are 12 years old, and they have learned to use GitHub. All of them. I can go on and say, okay, let's just you make a commit and push, and they know exactly what to do. Next step is learning them how to solve merge conflicts. So, and they would be very glad if you could follow them on their repo on the GitHub. Thank you.